Okay, guys. So our next step in this course is to start with the CAM, which is your CNC machining, computer-aided machining side of things. And basically, we've got to set this file up now for the CNC router. Now, just hide the top panel. You can see that we've already created flat panels on our previous design, which means that this entire thing can fit on a 16mm board. All these panels can fit in nicely together, and off you go. So the first thing that we're going to do is obviously to check for little design details like this chamfered top. We won't be able to machine that, so we'll just delete that and keep it in normal straight edge. That's something that we do in our post-processing after we've machined all the panels, and actually after we've assembled the whole table, then you can chamfer the little edges and you can do that little detailing type of thing. So it's a little bit pointless to do that in a design level, but yeah, it's just better to have flat panels. So yeah, we've got all our flat panels. Now the first thing that we need to do is flat pack all of these. Now you could manually flat pack these by simply selecting an item, flipping it with the machine face to the top, because that's how the router works, and then getting them all at the same level, hitting OK. And you could do that with all these panels, with all machine faces facing to the top. Okay, that's one way of doing it. The way that I do it is I've got this awesome little plugin that I've downloaded from the Fusion App Store. You go to the add-ons and you go to the Fusion App Store, and you type in map boards app. You'll see I think they've got two versions, which one is a pro version, the other one's like an entry-level version. I think I've got the normal version, not the pro version. Now, basically what this does is it flat packs all your components with the machine side up in one go based on the board size. It's not the world's best nesting tool, but it saves a ton of time with the flat packing of your items. So for the purpose of this exercise, I assume that you will download the version. Please support the creator of this Mapboards app. I have to say honestly, service, feedback, if you've got an issue and you send a request in, the response times are insanely good. Whoever is behind Mapboards, I can highly recommend spending the $14 or whatever it is for the app. It works wonderfully, and the support is top class. So download the Mapboards app. We'll simply click. Okay, so we hit the Mapboards thing. We basically wanted to give us a single board size. Over here, we've got one single board size, MDF, medium density fiber board, and the full sheet size. Now, these are my default setup because I use full sheets on my machines usually. But you could customize these to whatever sizes you want to use. You could have an offcut in your workshop that you want to use accordingly, then you can just scale it in there. The next thing is to go into the options. Now, the main thing here is to leave enough space between the components, which is 7mm. We'll be cutting with a 6mm bit, so it just helps. And then the trim on the edge of the board, I usually leave it on 5mm, and Z up, I save that as defaults, and those are my defaults. Simply hit OK, and you'll see it flat packs all these little panels, and off you go. Okay, so let's just hide the table for now. Now you can see all these panels have been flat packed, and it's absolutely, I mean, how quick was that? Can't do it quicker manually. This little plugin saves you so much time. It's insane. So now the thing that we want to do, before I rotate or do anything on this design specifically, I just want to mention, if we go to the manufacturing tab, and we wanted to do a setup, let's just click on setup for the moment. You'll notice that it creates a blank setup. Now, my defaults are set once again to 1.8 by 2.7 meters, which is this yellow block that you're seeing is my default MDF full sheet sort of setup. Now, yours might look a little bit different. You might not have the option to fit these in. You know, yours might by default be like this, depending on how you've set it up. So if I say fixed size, I've got my fixed sizes over here. That's my normal standard sizes, okay? Just keep in mind, those are defaults. Now, what you would do is you would select your model, which are all these little components that have been flat packed now for you, okay? you'll select that. Now, the one thing that you'll notice on the setup is that I've set up my machine as with the previous video. The y-axis is front to back, x-axis left to right, as you can see over here, and then the z-axis is the up and down. So in other words, we've got the y running across front to back, left to right, up and down. I hope that makes sense. So you'll notice that the model, as it was flat packed with map boards earlier, is tilted clockwise by 90 degrees. Now, we could leave it like this and still machine it and everything would be fine. But we'll go back into the design window for now. We'll click on the map board thing and just quickly rotate it by 90 degrees just to make sure that it fits the board like this. And then what we'll do as well is just hide these the bodies, sketches, and joints just to make sure that we don't see the actual board layout. Okay? Now keep in mind, mine is based on the defaults that I've set up. So if you set up and run a map board thing, you might get some labels, pre-made labels where they name the components and all kinds of things. Still does the same thing. I've just disabled those functions because I'm not worried about seeing what every panel is named. So that's turn clockwise. Let's go back into the manufacturing tab. And you will notice that if we select them, we get the bodies again. All the bodies are selected and we are good to go. Now, before we get started with this, I just want to mention that we are going to work with two main cuts in StockFit in general. Those two main cuts would be 2D pockets and 2D contours. Those are the two main parts that we will use. Now, what a pocket is you're teaching or telling the software to cut these type of pockets. It means it's not right through the material and it does like a sort of a clearance on a certain area. Like that's a pocket. These are all pockets. Okay, that's where the wood joins together in those 8mm slots, if you want to call it that. So we use a 2D pocket for that. Just make sure that you don't select 2D adaptive clearing. Those two icons are extremely similar. And you could very easily, I've found myself many times where I, by accident, select 2D adaptive clearing. It does a similar job, but you end up having quite a challenge to just get the stuff to work the way you want it to work. And you don't realize that you've actually selected adaptive clearing instead of a 2D pocket. Okay, so we work with 2D contours and 2D pockets. The standard workflow for me is to do all my pockets first, then do the inside contour cuts, and then the outside contour cuts. The reason why I do the inside cuts first is I don't want any parts moving around. So in this situation, for instance, I would cut these holes first before I cut the outsides. Now, as you can imagine, if you do the outside cuts first, these panels will be loose. So cutting these insides is going to give you a little bit of a headache if your vacuum bed is not absolutely perfect. And because if these parts move, then you won't get these accurate lines. So we cut from the inside to the outside, from the top to the bottom type of thing. So we start with the pockets from the top to the bottom because it doesn't cut through the material, which means no material moves. Then when we cut through the material, we cut from the we cut all our inside contours first, and then we do our outside contours last. Now, we can start with our 2D pockets. You'll notice on the right-hand side here, you've got a window that just opened. We're going to select a tool. We're going to select our 6mm square bit, which is a standard StockFit size that we use in our workshop. We're not going to have coolant enabled simply because it's a router. Our router is not a coolant unit. Although it's got its own cooling system to keep the spindles cool while working, it doesn't actually have coolant on the actual material while it works. That's more for metals and that sort of thing. Obviously, you don't want to spray MDF with water while you work because by the time you're done, you'll be sitting with mush. But anyway, so the next tab over here, we'll select our geometry. Now, this is where you select basically all your pockets that you want to machine. Now, I know that we're going to have a little bit of a glitch because I can already see it coming, but I'm just, for the purpose of the exercise, going to select these parts anyway to show you quickly what it is that I mean with this glitch. But anyway, so there we've got all those pockets selected, and we won't mess around with the other tabs at the moment. I think it's unnecessary, so we just hit the OK button, and off we go. Now, the one thing that you'll notice is that these parts are set up, but I don't know if you can see, but these parts aren't showing on these short little strips on the side here. Now, usually what causes that, I'm not entirely sure, why it would do that. But I've seen over the years that for some reason it doesn't do these clearances. Fusion's got some sort of reason why that I'm not sure what it is. But luckily, with a simulation, you can sort of open it in a simulation. You can select to see your stock and your parts and things. You can hide that, and you can simply hit OK, and it'll show you exactly how it machines. Now, I'm going to take it slowly here, just to show you that it doesn't do the clearances across that side that we need, which means that it's a bit of a glitch in our design. You will notice that as you work and as you improve with Fusion 360, that there are a couple of ways to work around this. Now, the way that I would fix this personally is to create small little tabs or little walls, if you want, sort of ribbing or something, just to separate those two parts from one another. So the way that I usually do that is to go back into the design window, and then on these parts, okay, there are a couple of ways to do this, but for what we'll do for now is I'll just split this body for the moment. Just capture it. Just split this body over here, and then split this body over here as well. Now you'll notice that I've cut through everything here. And then what I'll do is I'll just simply click here and extrude it by let's say minus 0.5. So it just drops it a slight little level down. Not much. I mean, it's hardly visible. And then I need the combine tool and then combine all these parts together as it was earlier. Join it. I'm not going to keep tools. And that's it. So you'll notice the difference between this one and that one. This one's got a continuous path and this one's got a slight dip. Now, again, I've had situations where I don't have to do this, where it machines perfectly around, and I've had situations like this one now where I can actually see that the path is a bit faulty. And this is the way that I fix it. Now, there are other ways to fix it, but this is for the purpose of this exercise, just do it this way. So we're going to quickly select everything there again, join it together, weld all the parts together, and off we go. And we can just quickly do it for this model as well. We've got 4 of those. I know that this is a bit of a pain, but unfortunately, it's one of the only ways to get this sorted out. Now, I'm sure that if you speak to someone at Fusion 360, they're going to explain to you exactly why this happens. But nevertheless, let's just get this going quickly. That's the last one. Split the body again there. Extrude by minus 0.5. Just drop it ever so slightly and then weld everything together. So basically what we did is we took the faulty areas and we simply created this little deeper cut line, which is very little by machine standards or by actual workshop standards. I mean, it's 0.5 of a millimeter. It's absolutely almost nothing, but it does create 2 different paths for the machine. So when you go back into your manufacturing tab, you'll notice that you've got this tool path that's out of date. You simply click on the edit, and what I usually would recommend is to delete all the paths that were selected, because we actually manipulated the paths that were created before. you might get an issue with these things. So we'll start off by selecting the path again. Selecting that one. Now you'll notice that when you select this path, this does not select. Just want to show you quickly. So those paths don't select in this specific file. We can select that and that. And we can select that and that. That. Hit OK. Oh, failed to generate toolpath. What's the reason for that? Model has 3. Oh, it's got 3 missing sections. Okay, so what happened there, just to fix that quickly, I kind of forgot that it was going to do that, but it's a quick fix. So when we did the setup, obviously when we altered this design over here and we tweaked this down, basically what happened was it took it from the component and turned into a new body in the design window. So on the setup itself, if we go there and we say edit the setup, you'll notice it says 11 bodies. Now if you select there, you'll notice 3 of those bodies aren't selected. Those are the 3 bodies that we welded in different sequence, and it actually removed it from the original setup. So we just have to go to the setup again and make sure that everything is selected. Hit OK. Now all the bodies are selected, and if we hit generate on this now, it should be fine. And off you go. So it works. So now, just for we could join all these short parts that we've created now into this 2D pocket. But I think let's duplicate this for now. And we say edit, and we just quickly remove all these selection chains, and we select the ones that we need over there. And I just want to check on it. No. We've got a couple of settings that we can tweak. I just want to see something quickly. So if I'm taking a little bit longer. Speed optimization. Okay, let's just quickly step through this. Sorry about that. I thought there are a couple of ways of tweaking this to go a little bit quicker, but let's simply hit OK. So now it's selected those parts as a separate one. So first one, we've got all of those, and the second one, we've got all of those. So basically what will happen now is if we select both these parts and post-process them for machining, we can select the configuration or the G-code format that you want to use. In our case, we're going to say G+. Now, I don't mess around with program numbers and all kinds of things. Document units would be millimeters. We stick to that because that's how we work. Now, if your setup is done in inches or whatever, then you're welcome to change it. So I don't mess around with any of these. I simply hit the post button, and it will ask me where I want to post, and I can choose my flash disk. Then I can give it a nice name and then say save, and it will save my G-code to that flash disk. But we're not done with this one yet. So we've done all our 2D pockets, okay? Working well, everything is done, and off we go. Now, the next thing that we want to do is do our inside contours. So we will select the 2D contour icon over here. You'll notice that the 6mm bit is already selected because we selected it in our previous tool. So Fusion 360 is smart enough to know that we've selected that, and it defaults to the previous one that we had. So from there we can simply click on the geometry, a contour selection, and we want to cut that bottom line. You don't want to select any other line by accident. You want to cut the bottom line because that's where you want the router bit to end. So the way I do that usually is to click on this on the cube and view my model from the bottom, and then select the contours that I want to cut out first. As I mentioned earlier, I do want to cut from the inside to the outside. So I hit OK, and you'll notice it's got all these nice blue lines. That's our path setup. Now we want to do our final cutout of the outside lines, and the way we do that is we can just duplicate this, go edit, deselect all our lines. Again, take a look at the model from the bottom and then select all the bottom lines of the contours around us. And you hit OK, and off we go. Now, there are a lot of technical things regarding the contours and the way that it's set up and the way that it works. Just as a quick sample, you can edit. We've got the linking tab, which means that you can deselect ramping positions. And there's a whole bunch of different settings that you can alter. The direction of your machining, how much stock to leave, how much stock not to leave. And we'll cover all of these in detail during later lessons. So we will go into 2D pockets and all the settings that and what they involve and whatever. But what we do in our stock fit setup is to actually do multiple depths. What this means is that the router bit doesn't just plunge right through the material and cut out aggressively. We systematically drop it into the material a little bit by little bit by little bit. So it spirals its way through the material all the way down until it cuts through. I don't like to just plunge a router bit through the material and do a brutal, savage cutout that's aggressive, because router bits break that way, material moves that way. It's not the way that I work. I believe that it helps to be a little bit patient with these sort of things. So we usually do multiple depths, which means that we'll go in at 4, 5, 6 mil or whatever at a time. And I also have the ramping enabled always, so that it doesn't just go down, it spirals down systematically through the material. That way your router bits last much longer. It does obviously take a little bit longer as well, but it's just a better way to do this. So yeah, we're not going to go into all of these tabs just yet. We'll hit the OK button. All these parts are done. Now what we can do is just simply right click on all of them, hit the simulate button. We're going to have the tool paths visible. We'll just have stock visible, and we can hit play and we can actually check what this thing will be doing for us. Speed it up ever so slightly. So this is what your router will be doing as it cuts out. All panels cut out, boom, done. Okay, so we know that we've got all our panels sorted out. You can see that everything's cut out beautifully and our G-code works fine. And that's it. So the way that the person can now, if you selected a single path over here, it will export a single path. Now it will also machine in the path sequence that you've got here. So what we've got here is got pocket number 1, pocket number 2. If we swap this around by dragging it up to the top, you'll notice that pocket number 2 is now there and pocket number 1 is there. So you can actually swap the sequence by dragging these items around. Again, start with the pockets, then go inside cuts and then outside cuts in that order. That's just the best way to machine. So we work from the top to the bottom and from the inside to the outside. So if you select one single path here and you right click and you post process it, you'll export only that pocket. Okay. If you select all 4 and you post process it, it will combine all these files into one single file that you can post. You can save it to your desktop or to your flash disk, and you can say, okay, side table design, and we hit save, replace it for now, and it's replaced. Now you've got the y-axis this way, the x-axis this way, z up and down, 16 mil, all the paths created. If I copy that G-code file, which I have over here, which is a side table design, if I copy this file onto my CNC machine, then I'll be able to run this file and it'll machine exactly this as you see it over here. So in our next lesson, we will get over to the machining side of things. We'll machine this panel and give you some visuals of how we go from software to the actual wood. I hope you enjoy that lesson.